So,
No, wait, not.
focus on yours.
I'm good.
What questions do we need to ask off of this homework? Oh, thank you so much.
Yes.
Crushing it.
That's what I'm talking about.
Wait. You know you didn't get this one signed at all, right? This one's good. That's the more important one, but I do also need that one signed.
Thank you.
Alright,
Oh,
so
bro.
we should have 5.5 out. We're not writing anything down, we're just asking questions. Because we are going to turn this in. What questions do you have about these answers?
I can't find mine.
Why did you write us a thing with a picture of a dog drinking milk?
Because I felt like it. What questions do you have about these homework questions?
Can I have the dog?
I don't have it, so no. There's no way for me to procure that dog for you.
Then that would be a no on the question.
So we're all good on homework. There's no questions about anything up here.
Oh, let me see.
No, there's not.
Mm-hmm.
No questions.
Alright, moving on in 3.
I'm just trying to get it out. I'm trying to find it.
You know the bell rang 3 minutes ago, right?
Yeah, I'm looking for it. I don't know. I put it in, Miss King.
You need to start getting to class earlier and getting your stuff out on time. Everyone else has their stuff out.
I can't find it. That's why.
Well, that's problematic. You need to put your stuff in order in the notebook.
I did minus
Please keep
5.
your mask all the way up. Say again, Peyton.
I did minus 5.
Hey, Peyton, are you supposed to be writing anything down?
To change the time.
Do not write anything.
Here.
You are just asking questions. We're going to give you feedback and write stuff down on there. Now, if you didn't do it and you want to make a note to one of us, hey, I didn't do this homework, but, so here, I'm just writing those answers down so that we know. Cool, but like, you're asking questions, we're going to grade it and give you feedback and put it in tomorrow. So you asked about number 7, right? So do not forget, it doesn't matter whether we're graphing or whether we're writing the inequality itself. What do we need to examine first?
Well, what I did first was pick a point to say that satisfy this solution.
But like you don't have an inequality, so you don't know how
Hey, I
to
know how to
determine if
do
that
it.
point
Look, I
makes
crushed
the
it.
inequality true, because you don't have an inequality.
Hey, I crushed
yeah,
it. I don't have
yeah.
it. Okay, so you find your x and your y intercepts.
Okay?
And then you find the slope, and then you put it in the equation, or you can also look at the line, and if it is dotted, then it's not equal to,
Okay.
and then you do the slope times x plus a point, the y point, the y.
Okay,
intercept.
so we are getting a lot of those good ideas, but we do want to make sure that we have a strategy or a pathway that will work really efficiently each time. Listen to the question I was actually asking. You hit a lot of the most important parts, but where should we start? Start with what? Okay, it doesn't matter whether we're graphing or whether we're writing the inequality, start with the boundary line. Right? The shading can distract you, but focus on the boundary line. Now you said some great things. You said find the slope, right? And find the y-intercept. So the y-intercept, notice how I said b equals 10 up here, Julia? B equals 10, y equals. So we're doing slope-intercept, at least based on that idea. Is it possible to do something other than slope-intercept? Yes, right? Like you can very definitely do point slope if you have a graph, but if you have the y-intercept, I'm going to do slope-intercept. So we have a b of 10, y-intercept of 10, and
Oh, I thought B was ready to change. Or the slope.
remember how m is being multiplied by x because
Okay.
multiplication is repeated addition, right? That multiplication being repeated addition is the rate of change. B is the y-intercept. But rise divided by run. So Kelsey, I don't know if you were using the x and y intercepts. I didn't, but you can for there's your rise. You're rising up 10. You're running 5.
And then 2 divided by 5 is 2.
Alright, so 10 divided by 5 is 2. Or 2 to 1. Notice I literally just took these two.
Oh,
Plus
yeah.
2
I just noticed that.
plus 1. Both work. They both give me a slope of 2. But knowing that, Julia, knowing that my slope is 2, my y-intercept is 10, I can write the equation for that boundary line. And all I have to do once I have a boundary line is figure out which direction I'm shading. Shading up or down. It's like, here's my boundary line. Am I shading above it or below it? So I'm shading up this way. So I'm going down. So would less than or greater than tell me to go down? The less than is what tells me to go down. So I've got my boundary line. Now I'm going to write the inequality. Y is less than 2x plus 10. Now you do have to make a decision. Is it less than or is it less than or equal to? Corel, how do we know when it's less than or equal to? How do I know when it's less than or equal to? I mean, there's the sign, but remember, I'm writing the inequality. I'm basing this on the graph.
Oh,
Kelsey, can you help us out?
Oh yeah, I'm sorry, boss.
How do we know when it's supposed to be less than or equal to?
The dot of the line. The line.
So remember, Corel, how we sometimes have solid versus dashed? So if it's dashed, like this one, should it be less than or should it be less than or equal to? No equal to, right? If it was a solid line like we have over here, that's when it's greater than or equal to.
Yes.
But because it's dashed, I just leave it like that. Does that make sense, Julia? So you're looking at that boundary line first, and then you're figuring out the shading. Now, we'll point this out. Someone got this one wrong earlier today. And you don't have to. One, you have Desmos, graph it, check yourself out, right? Use that to help you. Secondly, if this inequality is correct, every point in this shaded region should make this inequality true. Notice how I chose, I checked with 0, -6. And when I plug that in, I got -6 is less than 10. Is that true? So was my inequality correct? All right, so we want to pay attention to those kinds of details. All right? So leave it on your desk because we are going to continue with 5.5 now, but I will collect it in just a second. Julia, does that help hit some of those ideas that you were wondering about? So just don't forget, start with that boundary line and then use the inequality to figure out whether you're supposed to shade or above or below, or the inequality is based on the shading direction. So let us look at our objectives to wrap up 5.5. And so please hear me very clearly on this. You do need to have out this sheet of paper that I already gave you to do your homework on, or part of your homework on, and to do number 8 on yesterday in class. So you need that sheet of paper out for this. After we wrap up 5.5, we're going to move on to 5.6. We'll reserve about 3 to 5 minutes, probably closer to 5 minutes, at the end of today to look at a couple of problems from the homework to make sure we're all clear on what to do. Sound good? Who read objectives yesterday? Layla did. Who else? Desiree did. Okay. Peyton, can you read our first objective for us?
I can use a graph to identify the solution set for all inequalities in a system of inequalities that are represented algebraically.
So I can use a graph to identify the solution set for all inequalities in a system. All right? How do I identify all of the solutions for a system of inequalities? The boundary line is a part of it, but that's only the beginning.
Whatever is
Shade.
Okay, so we do
Whichever
shade with an
quadrant
inequality, but how do we know where the solution is for the entire system?
The shading overlaps.
Okay, so is this a solution to the system?
no.
No.
No. What about this?
No.
No.
Here?
No.
But I mean, there's overlap here, so why is this not a solution to the
It's not
system?
all of them.
It's not all of them, right? We've talked about this already up to this point. But if I want the solution to a system, it has to be where the shading is for all of the inequalities at the same time. Notice here it's just space constraint. Here I have feeding time and space constraint. Here I include the startup cost, but only here do I have all 4. We go with that idea? So we want to recognize that. How are we going to use that graph? We're going to look for where we have shaded solutions for all of the inequalities all at the same time. Today this is our focus though. Shelby, I don't feel like you get you to read objectives very often. Can you read this bottom one?
I can recognize when there are implied constraints represented with inequalities in a context that limit the feasible region.
Yes, I know it's a little awkward there, but we're looking for something called implied constraints today in a context that limit the feasible region, right? So I want you to think about it like logically. First off, we have these inequalities, right? But these inequalities do represent stuff, don't they?
Yeah.
Startup cost, space constraint, feeding time, and pampering time, I think is what those four are. So when I look here, these are just inequalities, and I do have the note of the constraints, but notice, and I know it's really dark, so it's harder to see, but if you get over here, you have negative number of cats. Is that actually possible?
No.
But do these points make these inequalities true?
Yes.
So there's a difference, you know, and we have to pay attention to this, between satisfying the inequality and satisfying the constraint or the context. Did we all get this graphed yesterday in class? Okay. So I see that you have your lines noted, but did you shade the correct direction for number 8? Can I see your graphs? Come on, I need to see it all down. And you make sure we all have a graph like we're supposed to. Okay? Close. Okay. Okay. You didn't shade it.
Yes, I got shaded down.
Okay, so I'm not going to, since we were most of the way there, I'm not going to spend a ton of time on this, but I do want to point out, nope, none of those are black, share the blue,
What am I doing?
and black. Okay, so, not going to spend a ton of time here, but I need to make sure that you all have this. Notice I'm going to my space constraint, I'm going to my startup cost, pampering, and finally feeding, okay? So what am I looking for to know where the solution to the entire system is?
Underneath all of them.
Where we have all 4 colors. And this is part of the reason why I like to use color coordinating. It helps me see where all of the inequalities are being satisfied. And so on number 8, right, so you already have this graph. Some of us have the lines marked, but you need to have this marked as well. And then we need to identify the region where the solutions are. So where should I be shading? Here?
No.
Here?
No.
Here?
Yes.
Okay, so I'm going to shade here. So where am I going to stop in respect to going up?
Huh?
The boundary line of space.
Oh, yeah.
Remember, I can't go above that, okay? So I have all this. Should I continue shading here? What about up here?
No.
Here?
No.
Okay, so I'm going to this boundary line now. Okay, what about here?
No. No. No.
Okay, so I'm going to this boundary line.
Yeah.
Okay. So you should have all of that region shaded, which some of us already have that done. If you don't, I need you to do that ASAP, like now.
Oops, I messed up on
I know a handful of us are already there, but does that make sense though why it's only here?
that. Yeah.
Have you like darkened that? I guess you did.
Yeah,
Lovely.
I didn't see it though. But it's all good. Why did you think?
Okay, I would like just use your pencil for that to make sure it's clear that you can see it. Where's your graph, Peyton? You haven't even gotten it out. Okay, so we go with why it's in that region, why it's all that. Nicely done. Good job. Alright, so as we just pointed out though, all of this is being shaded, but if I look right here, that's negative 10, 4. Is that actually a possible point?
No.
No. Why is that not possible?
No negative dogs. Or cats, or whatever.
Well, which one is this?
I don't remember. I think it's cats.
That's
No, dogs.
What was on the x-axis?
Dogs.
X was cats, Y was dogs. that dogs or cats?
Dogs. The cats. It's cats.
X, Y.
It's dog. X, Y.
Oh wait, that's cats, I'm stupid.
Which one is it?
Cats.
Cats?
Sorry, I lost a brain.
Not sure, Julia? You said dogs originally, you still thinking it's dogs?
I think it was cats.
Why was dogs X goes?
So notice, we have our X value here, and our X is the cats, right? There we go, okay. So we'll make sure we're all on the same page. So negative 10 cats, 4 dogs. Can't have negative cats though, that is kind of impossible. We all get with that idea?
Yeah.
So that's where this next question comes up, number 9, which I asked you to look at for homework. So this will be on the other side of your paper, okay? So on the other side of your graph, sorry, Julia, the graph that you did, yep, on the other side of that. There you go. So you should see in the top left-hand corner that says for 5.5, number 9. Okay, go ahead and keep doing that and you'll be able to catch up pretty easily. So number 9 says, only shade a region where?
On the first
Quadrant.
quadrant.
Quadrant, right? So quad meaning 4, there are 4 quadrants. Okay, so only quadrant 1. So I need to erase some of this, don't I?
Yes, you do.
Okay, so y'all have just a whole separate graph, but what I'm going to do is I'm going to erase it to satisfy this number 9 here. So when I start erasing things, where do I need to erase?
You need to erase under the cat's line.
So what is this cat's line called?
Y, X.
X-axis. So everything below the x-axis I need to get rid of?
Yes, you do. And
Okay.
then on the.
So notice everything below this x-axis would indicate that we have a negative number of dogs.
So that's
Not
an
possible.
implied constraint.
And then on the
Left?
left of the dogs. Left of the dogs.
Let's work on that language a little bit more.
Left
Left of the y-axis.
Okay, there we go. So we want to work on that language, right? So notice you said, okay, we need to erase everything below the x-axis
And anything on the second
and
quadrant.
anything in the second quadrant. Nice language, right? To the left of the y-axis. Those are just not possible, right? I cannot have a negative number of cats. Okay.
True statement.
And so I've already seen y'all's, and I'm going to shade it a little bit darker. What we're only left with is this. Alright, so below those boundary lines, those constraints, but then above the x-axis and to the right of the y-axis. What is this region that I just shaded really heavily?
The
That
only
is the-
possible
the-
real
the-
solutions.
The only possible solutions, what would we call that region?
That satisfy.
The first quadrant.
In the what first quadrant? What? First quadrant.
Those are the combinations of cats and dogs that work in the first quadrant. By the way, Desiree, if you turn that graph paper over that you had earlier, you can find the graph for this for this number
The
9.
only possible solutions. Because, yes, they have.
That's
The
it.
other ones could be solutions for the what you call them too, but those are for the word problem.
Okay, so
We've already discussed it.
all of this works for just that generic inequality, right?
Yes, that's what I'm
But
saying.
this is only what works for the word problem?
Yes,
Does anyone know what this region is called?
it's the
First quadrant.
it's the.
Do I have the entire first quadrant shaded? No?
It's a half and a third.
Hey. Well, first off, I do want you to remember, this continues to infinity,
Oh,
this
yeah.
continues to infinity, so is this really a third?
No. just
No, it's only a small part of it. Have you read all the way through number 9 yet?
Oh, the feasible region.
Thank you, right?
Show me.
Come on, it's right here, right? It's bolded.
I was gonna read that.
So even though we had all of this, only this is actually feasible. And why is that?
Because it can satisfy every single one of those 4 things.
But I mean, this point satisfied all 4
I mean,
constraints.
Because it's
That-
an implied constraint.
That is
You
actually
can't cut a
possible.
cat in half.
It's actually feasible.
So
I mean, you can-
notice the language that
But
Peyton
yes, you
used,
said
that paying
you-
attention to our objectives,
So shut up.
implied constraints. Now it's not as much about the halves, because let's be real, it's a little
Well-
awkward, but like right here would be half a dog. Can we have half a dog?
I mean,
No.
you
But
So-
you can.
Wait, but you're not in the negative.
But does a negative half, and that's my point, right? This would be 1/2, a positive 1/2.
Oh, okay.
So notice we're still shading those fractions of dogs and cats. Now that's not quite possible. It has to be integers or whole numbers. But more is right, okay, can I have a negative number of cats?
You can get rid of cats, yes.
No pain.
They're preparing to take cats on. They don't have cats. They can't get rid of any.
Okay.
Right? Remember, they're setting up a business to take care of cats.
Right, but how do you know they don't already have them?
Correct. I hope that no one is paying Carlos and Clarita to take care of their cats, as in, that'd be unfortunate, right? That is not cool. But yeah, we can't have negative cats or negative dogs. So, what we want to notice is this is called a feasible region. How is the feasible region shaded in number 9 different than the solution set to the system shaded in number 8?
Because it's only the possible ones, whether opinion said that's objective, in the objective, those words, that's that.
What Peyton said in the
What
objective.
were the words that Peyton said? Because we need to know those words.
I know it, it's implied constraints.
Okay, so we're looking at implied constraints. So in number 8, we identified
All the possible ones.
all points that satisfy the what?
The system thingies,
System of what?
inequalities.
That satisfied the system of inequalities. But what was the issue in number 8 of identifying every point that satisfied?
Negatives.
We did not add the implied constraints.
We did not acknowledge the implied constraints, right? That yielded, so we identified all points that satisfy the system of inequalities. So that yielded negative, or negatives, right? Just we can't have negatives with cats and dogs, right? That is the solution for the system, but we want to recognize we identified all points that satisfy the system. By the way, this goes under number 10. This is one of the most fundamental things, or one of the most important things that you need to be writing down for this problem, or for this task. However, in number 8, or number 9, what did we do?
We only shaded the part that's what's not visible.
Okay, so we looked only at possible combinations. Which had positive numbers of cats and dogs. And so Peyton used this language earlier. What were we missing in number 8 that we included in number 9?
Implied.
We had to look at the implied constraints. We had to acknowledge the implied constraints.
I think if everybody is corona, it will move me.
No, because everyone would have corona.
No, but if everybody got it and everybody got it,
Well,
Yeah.
so you know in England, they're dealing with new variants of COVID-19, which are reinfecting a whole bunch of people and is spreading more quickly than the original COVID-19 did.
As
We have it here too.
As well
Yeah, I
as
thought we were here, but I know it's really hitting England hard.
Yeah.
As well as Africa, they have a strain that's
Hold on, I got two
stronger.
people talking. What were you saying, Peyton?
In Africa, they have a strain that they just discovered that's only 2 or 3 cases so far. In the United States, it's stronger than all the rest.
Fine. What were you saying, Desiree?
So I thought England was like the only country that didn't have.
England? No, England has tons of cases.
Uh,
New Zealand has probably the lowest rate of cases, but they also have like the most strict policies on travel and things like that. Okay, so what is the first constraint that we're really looking at here that was implied? It was not given to us, but it was definitely implied.
you can't cut a dog in half. So
I mean, while that is true, I mean, do we have points in here that might include half of a dog?
Yes. Negatives is what it is.
Right, so you are correct, and like when we look at this on our own, we would have to acknowledge that we can't have part of a dog or a cat. But when we look at this graph, what did we cut out? We cut out what negatives?
What?
Which negatives did we cut out?
The
Say again?
negative dog cats.
Okay, so we first cut out the negative cats, didn't we?
Yeah.
Okay, so first off, the number of cats had to be what? So greater than or equal to,
1? Because you can't have 0 either.
you can't have 0 dogs or 0 cats?
Well, yeah, you can. You can have none. Yeah, we can have the dog cats.
So did it
and
need to be
the
greater than or
lions.
equal to 1 or greater than or equal to 0?
0.
0.
0. So what I want to translate that into is this idea. This is important to recognize. Weren't we originally shading to the left here? So you're telling me that there is a line right here that all of a sudden stopped that shading?
Yeah.
What would that line be called?
An implied constraint.
It is the y-axis, it is an implied constraint, but what is a line that tells us where to stop
Boundary line.
shading? Is that a boundary line?
Yep.
Oh. So these implied constraints still have boundary lines, and I want you to notice which direction are we shading in respect to this boundary line.
Right.
Yeah.
We're shading down,
To the right.
to the right. Do we have shading to the right of that line?
Yeah.
Okay, so I want to write an inequality for this implied constraint. Where do I need to start to write an inequality?
Find
The Belgian.
yes, boundary line. Yes.
We all agree boundary line? Has that changed yet? Anyone know what this boundary line is going to be?
B and the x axis.
Well, I thought we were looking right here.
Ah, but you can't be there either.
Yeah, but we're not there yet. We're still
Oh,
on,
okay.
the number of cats had to be greater than or equal to 0.
Oh, okay. What?
So does anyone know what this boundary line would be? Like, how would I write the equation of that boundary line?
Y. Y axis.
So it does go up to infinity, and it goes down to negative infinity, but is that an equation for the boundary line?
It's 0.
There's a 0 in there?
It's x. No.
Is 0 x?
0 is a y.
Okay.
So does x, y greater than equal? I mean, y. I don't know.
Let's be real with each other. Have we done a lot of vertical and horizontal lines?
No, I
We
remember
have
them
a
a little
couple,
bit.
but
Remember it a little bit? It's okay. Let's remember this though. Whatever equation we write, every point on that line needs to make that equation true. So could we look at some points on this line?
yes.
Okay, so like if I look right here, that's 0 in the x, 18 in the y. That's 0, 14. That's 0, 6. That's 0, negative 2. And 0, negative 6.
I feel like y equal.
No, x is
What is this?
equal to 0.
So let's ask y'all.
No, just kidding, I
Just
don't know.
think just.
If I look at every single one of those points, does x equal 0?
No.
No,
Yes.
Yes.
what?
No, yes.
To that.
It's yes or no, Kelsey?
No,
You
I'm thinking the
know.
wrong thing.
Yeah, no. I mean, look, are each of these
Yeah.
x values 0?
Yep.
Yeah.
Yeah.
Yes.
So is this equation that Kelsey wrote correct?
Is it?
Yes.
No, wait,
Does
what?
every point on that line make that equation true?
Yeah.
So is that a correct equation? Horizontal lines and vertical lines are different than the other equations we've written because the slope is a little different, things like that. But the fundamental truth is, hey, does every point on that line make this equation true? Yes, so we're good to go. That's where if I have a horizontal or vertical line, I'm just going to look at a handful of points and figure it out. Now, that's my boundary line. What is the inequality or the constraint? Why don't you read what we wrote above it?
And the black or the what? Oh. Yes, has to be zero. Oh, so it'd be greater than or equal to and zero.
Let's look over here. We got our 0, and we are going to the right, which is greater than.
Infinity. Oh.
I mean, it does go out to infinity, so we have some constraints over on this side, but it's greater, it's going to the right, isn't it? Okay? So we have the inequality x is greater than or equal to 0, and I want y'all to notice this, because this is what I love about math. The number of cats had to be greater than or equal to 0. Doesn't that say exactly the same thing?
Yes, it does.
Which one's easier?
That one.
If you know how to read it, if you understand that, hey, x is my number of cats, then you understand immediately, hey, the number of cats has to be greater than or equal to 0. This is where math is beautiful in that we can make sense out of the world in a much simpler way once we get comfortable with it. I do want you to recognize that. Are there any other constraints?
Yes, there
Dogs
is.
can't be 0.
Okay, so
I mean,
can it not be 0?
no, it can be 0. It just can't
It
be
can be.
So the number of dogs has to be what?
Less than greater than is zero.
Which one?
What?
Less than or greater than 0?
Less than.
So if you're less, give me a couple numbers that are less than 0.
It cannot be less, it's like greater.
Why can't it be less?
It can't be less because you can't cut a dog, okay? You can't give a dog away.
No,
So-
no, you can't have negatives.
Right, so you can't give the dog away.
So remember,
Yeah,
if
negative.
it's a positive dog, and I think, so I will say, Peyton, don't forget, we're ignoring the half a dog deal, right? Because that would just be awkward and we can't really deal with that. But the idea is, if I'm gaining a dog, that's a positive, right? So the idea of giving a dog away would be a negative. However, should Carlos and Clarita be giving away anybody else's dogs? No, right? Those are those other people's dogs. So the number of dogs has to be greater than, I'll get it later, focus now, or equal to 0. So what would be that boundary line?
It would be the x-axis.
I mean, to be fair,
But what would the equation for that boundary line be?
what if they can't deal with the dog?
It would be
That's not
y.
Carlos and Clarita's job to give away those dogs.
Y